morning, this is Dr. Shaik Maheboob, Associate Professor in CSC Department. In the previous session, we have discussed the various concepts of design engineering. Now, today we are going to discuss the next part in the design engineering, that is how to develop the data design, how to develop the architecture design, etc. So, let's start our session. First, we'll see what is the meaning of the design engineering. So in this one we are going to use the design models, various types of the design model. So what is a design model means? It is the blueprint of your software which is going to describe the structure, we can say, or how the system is going to be developed. Okay, so it is going to be done with the help of your SRS document. Means after taking the requirements, the next phase comes is data design model, we can say, right? So it is going to translate whatever the SRS document into some type of a structure. So in this we are having the various types of the design models like data design. So we'll see that one, architectural design, user interface design, component level design. So as I said, design model is one of the important part for the development of software because it is going to provide one type of architecture for your software. Now we'll see the next, that is one by one. First we'll see about the data design. So in the data design, it is the process of how the data is arranged or how the data is structured or how the data is stored into the system. So in this one, so the data design may contain some files, it contains some data structures, and then it contains some databases, and it also show the relationship among the various components and some constraints, right? So what are the benefits means? If we use this type of the data design, you're going to ensure the efficient storage and retrieval of the data, and duplicate data can be removed easily, that is reduces data redundancy and maintain your data consistency, support the decision making, and forms the basis for database design. So if we go with the data design, we are going to get the following benefits. Now we'll see what is the meaning of this data structure. So data structures, it is the, you can say, it is going to show the overview of how the data is stored. Okay, so it may be in any format like stacks, queues, linked list, or arrays, right? So these are the example trees. So maybe in the linear format or non-linear format data structure, we can say. So for example, a student structure contains what, like this: roll number, name, marks, etc. Then second is what, your database design. So in the database design, mostly we are going to refer with some entity relationship diagrams. So how the entity contains the list of the attributes and how it is related with the other entities. So like here one example is there for the ER diagram, that is student enrolls for n number of the courses. So one student can enroll the n number of the courses. So these are the list of the attributes, and here also course ID, course name are the list of the attributes. So this is how the database design can be done. Then other examples or other way for a data design is the file organization. So file organization means we are going to arrange the list, right? So in any format, maybe in the order or other, any linear order, non-linear order, etc. So same way, this is one of the example how we are going to design the data. So it may be like student data, course data, result data, etc. This is how we are going to organize the data. Then we can also use some of the data models for the database design, like physical model, logical model, or conceptual model, right? So these are the some example about how we are going to design the data. Then now we'll go for the next type of the design, that is the architectural design. So architectural design provides the overall structure of the software, we can say. It is going to describe the various types of the modules or set of the modules, and it also identifies the layers subsystems, etc. It acts as the blueprint of the system. So before going or before sending to the coding, this is the you can say final type of the structure or the architecture we have to provide, right? So what is the purpose of the architectural design means? It is going to provide the structure for the system, and it is going to manage your complexity. It also ensures some quality attributes like better performance, scalability, security, and maintainability. And it also guides developers during the implementation. So if we are having a proper type of the structure or the architectural design, then it will also help the developers or the coding team how to write the module or how to write the coding for that particular component. So it will be very helpful for the developers, and it will also improve the communication among the stakeholders. So stakeholders can easily understand if we provide this type of the architectural design, that how the software will be look like, etc. Now next, so we will see the various types of the architectural styles. So we are having some of the architectural styles, some list of the 5 architectural styles that are commonly used for the architectural design. So one by one we'll see what is the purpose and examples. So first one is the layered architecture. As the name itself is giving some main, it is divided into certain layers. So maybe business layer, presentation layer, data layer. Okay, so we are having the system, complete system is divided into some set of the layers: database layer, data access layer, business logic layer, presentation layer, etc. So this type of the architecture mostly used in the web applications. Then second type of the architecture is the client server architecture, where client sends the multiple types of the request or a single request, and the server is going to send the responses to the client. So mostly we are going to use this also in the some email systems and web applications. So here if you see the structure, here client is there and database is there. So every time the client is sending some type of the request to the server is connected with the database and the other type of the storages, right? So every time it is going to send the request and the server is going to send the responses to the client. So in that way we can use it client server architecture. Now third one is the microservices architecture. So in the microservices architecture, the system is splits into some small independent services like order service, payment service, inventory examples, right? I will show you that example. Each service performs some specific type of the task or the function. So clients are the users, so communicate through the either the system or the mobile application. So here one architecture for this microservices architecture. So here it contains the services like which is going to perform some specific function, like order service will be there for processing your order, and payment service is for your doing the payment, right? Inventory service to search about the various types of the products and related to the processing, and notification services for after the product is ordered, then we can say it is sent to the notifications that it is on the way or where is the status, like that. So this is mostly used for the like Amazon or Flipkart, we can say. Based on that we have draw this diagram. Okay, so this type of architecture is there, which we call it as the microservices architecture. Then other type of the architecture is the model view controller, that is MVC. So in this one we are going to use the 3 types of the components, that is model, view and controller. So model contains some data, you can say, and view is used for viewing the components like user interface, interaction will be there. Okay, how it is going to communicate. Then controller contains some type of the logical data. So it is mostly used in some frameworks like the Django or Spring, etc. So whenever a user want to use this type of the architecture, then if you observe carefully here, the user uh, sending the request to the controller, and it is going to see the updates, right? It is going to see the updates in the view. So user interface here, through which it is going to communicate with the model, right? And whatever the updates are there, it will be passed through this model. So this how we are going to get the model view controller. Now next and last one is the pipe and filter architecture. So if it shows how the data is flows. So in this pipe and flow architecture, the data flows through the filters which are connected by the small pipes, you can say. So for example, compiler design, it's the best example for showing the flowing of the data, where we are going to flow the data from one module or one phase to another phase, right? Input is there, like we are going to send some type of the input, it is going to process through the process 1, process 2, process 3, and finally we'll get the output. So best example you can remember is the compiler design. Okay, how the data is flows through the pipes or through the filters. That is all about your pipes and filters architecture. Now why we are going to use this one? So what is the process of this architectural design? We'll see. To better understand the system requirements, we are going to have this design process. Then identify the various types, as already I said, various types of the system components or the modules will be there. We have to identify that one, and it is going to define the relationship among the various modules or various components or subcomponents, and we can choose the architectural style, right, for this architectural design process. And it also define the interfaces and the interaction between the various components and various submodules, etc. It is going to, then we can go for the evaluation of the architecture, like whether it is giving the full good performance, scalability, security or not. So that is the architectural design process, starting from the understanding level of user requirements and system requirements to evaluate the architecture. Now we'll see the third type of the database model, that is user interface design. So in this one, the main part of the how the user are going to communicate with the system. So for that purpose, we need this type of the user interface design. So it is going to define how the different components are interacts with the system. As I said, so what it includes some type of the user interfaces, some system interfaces like APIs, and focuses on input output formats, screens, and interaction flow, and ensures the ease of use and consistency. Define communication between the various modules. So we can say interface design is mostly used for the user. So how the users are going to communicate with the particular application software or particular system, that we are going to evaluate in this user interface design. Okay, so this is the process for user interface design. So we are having around 4 types of the phases are there. So in the first phase, we are going the user task environment analysis. So that is the main focus is based on the profile and who are going to interact with the system. So it means what, who are going to be users, we can say, right? So that will be analyzed here. The focus is based on the profile of user. It means what type of the user are going to interact with the system from that particular application software. Then second phase is the interface design. So in that interface design, it is going to define some set of the interfaces, objects, and the actions. So here we are going to define some type of the interfaces through which the user interact with the system. Then third phase is the implementation. So in this one, we are going to create one type of prototypes. Okay, one prototype or model will be created which enables the usage scenario that is to be evaluated. So here implementation phase, we are going to create the scenario or you can say creation of the prototype for the user interaction. Then finally, once if it is created or implemented, the next and final phase is here interface validation. So here this phase is deals with the testing of the interface. Means if we touch, for example, in the apps, Android apps, if we touch on that particular application, whether it is working correctly or not, whether it is giving the responses or not, like that, right? So once it is tested successfully, we can say it is validated. Okay, so these are the various types of UI design phases, right? So simple example about the UI design, like for the student management system, we are having some headers are there. So if we observe carefully here, suppose if we click on this one, admin, it should perform some type of the action. So that is to be validated, right? So here we are having some navigation menu is there, dashboard, here sidebar is there, optional, you can say buttons are there, and these are the set of the modules are there, right? So that is one of the example for UI. So whenever we are going to click on either dashboard or student courses, exam reports, etc., it should perform some type of the actions. Then we can say that interface validation can be done for this, right? Here whatever the main content is there, so information will be displayed in this format, right? Then we are having the footer and the forms like student management system or whatever the inputs are there. If you want to add, you can add it as a search box. Then here this section shows the footer, right? This is some just a simple example about the user interface design, through which we have to evaluate all the four phases what we discussed previously, and once it is completed, the interface is validated, we can say, right? And that's all about your user interface design. Now next type of the design model is the component level design. That is the last one, in which we are going to discuss about this database design models. So here component level, so component means first we understand the meaning of the component. So components are the some main type of the modules which we are going to be used in our application. So how to design that components, that is the meaning of the component. So component level design is one of the important part, we can say. And it focus on the internal structure, like I shown one example here, dashboard, student courses, these are the components, we can say, or set of the modules. So here it focuses on the internal structure and working of individual software components or the modules. So after the architectural design identifies the major software or system components, then component level design explain how each component will process the data or perform the functions and interact with other components. Like these are the individual set of the important component level components are there, right? So this is the component level design, we can say, right? So here it is going to provide the information which is very important for the particular applications, right? So same way here it contains how we are going to process the data, how we are going to perform the functions, and how the modules are interacted among each other. Okay, so component level, so design focuses on some internal detail of each module, as I said already. So it is going to describe the algorithms, logic, and data processing. It breaks the system into small functions or small units, that is classes and functions, and supports the coding directly from the design, and it emphasizes the low level design details. So if you observe here, suppose if you click on the dashboard, so we are going to see one type of a dashboard. So dashboard is one of the component here. So inside that one, what the content are there, that is comes under the low level design details. That is the meaning of emphasizes the low level design. So a component may represent any type of the functions, class or module or submodule, subsystem, etc. So each component is designed independently so that if any type of the changes takes place, it should not affect on the other component or the other modules, right? So good component design follows some two types of the important principle, that is the high cohesion and a low coupling. So high cohesion means what? A component performs a single well defined task right? While low coupling means components have minimal dependency on each other. That are the main important principle of the component level design: high cohesion and low coupling. So the major elements of component level design includes modular design. So modular design means here it is going to define the various types of the functions, tasks, responsibilities of that particular module. Then data structures, it is going to define the various types of the variables, objects, files, and the internal data organization. It may arrange in what type of the data structure it is arranged, either list type or arrays type or stacks, etc. Then algorithms, it is going to describe the step by step processing of the logic used within the module or component. Then interfaces, it is going to defines the communication between the modules through function calls or the API. So interfaces are also one of the important component or important element of your component level design, through which we are going to communicate with the user. Then finally we are having some exception handling element for component level design, which is used for handling the any type of the errors are there, okay, or any abnormal conditions effectively. So that is all about your component level design, okay. So for example, for this component level, I have taken one example about the ATM diagram component design. So here if you observe carefully about this component design, like one module I have taken for this, in this the withdrawal concept is there. The user is going to be add the card, right? User input, right? It accepts the account details and amount as inputs and verifies the pin. Then once the pin is verified, checks the account balance and update in the databases. And finally, if the balance is there, we can say it is going to dispense the cash. If the database shows the invalid pin, then automatically it will show as the invalid pin. And another, if balance is also not there in your system, then also it is going to show an error as the insufficient balance. This is how we are going to show one of the component level design, we can say, for the ATM system, right? So all these internal operations are specified in the component level design before the coding begins. So before this type of the design, before forwarding to the coding team, we are going to describe this component level design, okay. So once we perform all the operations, it is going to print the receipt and the transaction is completed, right? So this type of this, you can say, design we are going to be implemented in the component level design and forwarded for the coding, okay. So that's all about today's session. In the next session we are going to discuss the other concept of the design engineering, that is the unified modeling language and various types of other design concepts and various types of the diagrams. What are the things are there, relationships are there, diagrams are there, what are the building blocks of the UML. So I've taken the some of the references for these concepts, like books and reference book and some electronic resources. Thank you and have a nice day.